The formation of the moon. Have you ever looked at the moon and wondered, how did it get there? That glowing sphere that lights up our nights, controls the tides, and has inspired myths for thousands of years, was once part of a violent cosmic event. Today, we'll explore one of the greatest mysteries in astronomy, the formation of the moon. 1. The early solar system, a violent beginning 4.6 billion years ago. Our solar system was a swirling cloud of gas, dust, and rock called the solar nebula. As gravity pulled this material together, the sun ignited at the center, and around it formed countless chunks of rock, the early building blocks of planets, known as planetesimals. Among them was a young, molten Earth, not yet the peaceful blue planet we know. Back then, Earth was covered in oceans of magma, bombarded by asteroids and surrounded by thick toxic gases. It was chaotic and dangerous, but it was also the stage for something incredible, the birth of the moon. 2. The giant impact hypothesis. The most widely accepted theory for the moon's formation is called the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized planet named Theia was traveling through the solar system. Theia and Earth shared a similar orbit, slowly drifting toward each other, until one catastrophic day. They collided. The impact was unimaginable. Theia struck Earth at an angle, releasing energy equivalent to billions of nuclear bombs. The collision blasted huge amounts of molten rock and vaporized debris into space, forming a glowing ring of hot material around the Earth. Over time, gravity began to work its magic. The debris from this violent impact started clumping together, bit by bit, forming a new body. That body became the moon. 3. The moon's birth. A molten world. The newly formed moon wasn't the cool, calm place we see today. It was a ball of molten rock, glowing orange and red, constantly bombarded by leftover debris from the solar system's formation. As it cooled, heavier materials like iron sank toward its core, while lighter elements formed the crust. Volcanic eruptions shaped its surface, creating vast plains of dark lava we now call Maria. If you look at the moon through a telescope, those dark patches are the frozen remains of ancient lava seas. Back on Earth, things were just as dramatic. The collision with Theia had tilted our planet's axis, giving us seasons, and sped up its rotation. A day on early Earth lasted only 5 or 6 hours. 4. The moon's influence on Earth. As the moon settled into orbit, it began shaping the Earth in surprising ways. Its gravity created tides, pulling on our oceans and slowing Earth's spin over billions of years. Without the moon, Earth might spin much faster today, causing extreme weather and shorter days. But the moon also stabilized Earth's tilt, preventing wild swings in climate. This stability may have been crucial for the development of life. So in a way, the moon didn't just form from Earth, it also helped Earth become what it is. 5. Evidence for the giant impact. But how do we know this story is true? The answer lies in moon rocks. When Apollo astronauts brought samples of lunar soil back to Earth, scientists discovered something fascinating. The moon's rocks are nearly identical in composition to Earth's outer layers, but with fewer metals like iron. This supports the idea that the moon formed from Earth's crust after a massive collision. Computer simulations also show that a Theia-sized impact would produce a moon with the exact mass and orbit we observe today. Even tiny differences in oxygen isotopes match, suggesting the Earth and moon were once the same world. 6. Alternative theories. Other possibilities. Of course, science is always open to new ideas. Before the giant impact theory became dominant, there were several competing theories about the moon's origin. The fission theory suggested that the moon was once part of Earth and spun off when the planet was still molten. The capture theory proposed that the moon formed elsewhere in the solar system and was later captured by Earth's gravity. The co-formation theory imagined that Earth and the moon formed together side by side from the same cloud of dust. Each theory explained part of the mystery, but none fit all the evidence as well as the giant impact hypothesis. Still, new data from lunar missions continues to refine our understanding. 7. The fate of Theia. What happened to Theia after the collision? Scientists believe that much of Theia's material merged with Earth, forming part of our planet's core, while the rest became the moon. In a way, Earth and moon are two halves of one ancient world, forever connected by a shared past. In the billions of years since its formation, the moon has changed dramatically. It's slowly drifting away from Earth at a rate of about 3.8 centimeters per year. That means when dinosaurs roamed the planet, the moon was much closer, appearing larger in the sky and creating stronger tides. Over time, countless asteroid impacts scarred its surface, leaving the craters we see today. With no atmosphere, no wind, and no rain, those craters remain frozen in time, silent witnesses to the early chaos of our solar system. 9. The moon and life on Earth. The moon may also have played a role in the development of life. Tides caused by the moon could have mixed nutrients in Earth's oceans, helping the first living organisms evolve. Its gentle light may have guided early nocturnal animals. Even human civilization has been shaped by the moon, from ancient calendars and myths to space exploration and dreams of life beyond Earth. Even today, scientists are still uncovering new secrets. Recent missions have found traces of water ice in permanently shadowed craters near the lunar poles. These discoveries could help future astronauts live and work on the moon. Some researchers even suggest Thea's core might still exist deep inside Earth, a hidden remnant of that ancient collision. Every rock, every crater, every grain of lunar dust tells part of this incredible story, the story of how destruction became creation. 11. The moon as our cosmic partner. The moon is more than just a satellite, it's a cosmic companion. It has guided our evolution, shaped our tides, and lit up our nights for billions of years. It reminds us that even from chaos and violence, beauty and balance can emerge. The next time you gaze at the full moon, remember, you're looking at a piece of the Earth itself, a silent witness to our planet's fiery beginnings. If you enjoyed this journey through time and space, make sure to like, share, and subscribe to VividNova, where we uncover the wonders of science, nature, and the universe. Until next